Assalamualaikum and very good day to our lecturer, Dr. Zuria. My name is Siti Nafisa binti Muhammad Fasinat on behalf of my group. I would like to welcome to our video presentation for the BTM533 Business Solution and Design course. Today, we will be presenting our group project entitled Smart Cafeteria System. To start this presentation, I will pass to next member. Thank you.
Assalamualaikum, my name is Nurul Syahir binti Saidun, and today I would like to talk about introduction of the Smart Cafeteria System. University Teknologi Mara UiTM Cawangan Pahang, Kampung Jengke is a highly prestigious and significant university located in Bandar Jengke, Pahang. Many students and lecturers depend highly on the services offered by the food service points within the university daily. Some of the main food service points within the university include the student cafeterias, which are inexpensive and easily accessible, and which are the primary sources of food at the university. With the increasing need for digitized solutions within the university, there is currently a need for a better and more efficient dining information system at UiTM. To meet this need, there is a proposed solution of developing the Smart Cafeteria System, SCS, which will be a digitalized food stall management system using a mobile app. This application aims to transform and improve the current cafeteria system by providing a structured platform that combines live menu tracking, stock monitoring, and operational updates into one seamless interface. SCS is introduced by our team of UiTM students who recognize the daily struggles faced by the campus community. With critical concern regarding the current lack of information, such as students walking to cafes only to find food completely sold out, facing unexpected ingredient shortages, or finding store closed earlier than expected. This application serves to ease the meal planning process with just a few clicks. This app was developed based on the true daily practices of students and faculty who have busy lecture timetables, but it comes with digital innovation that enhance usability and service delivery. The main concern of SCS is to make things convenient, minimize time wastage, and provide real-time services to their users. It also helps in managing operations effectively for the cafeteria vendors of UiTM campus Jengke. Next is the explanation of the current system. The present system of monitoring and dining currently implemented by students and employees at University Teknologi Mara UiTM Cawangan, Campus Pahang, Jengke, is fully done manually without an official system or update through the internet. To find out the type of food being served, the students and employees must physically travel to the stalls in the cafeterias just to see the menu board. The system works totally based on the physical presence in operational hours, as there are no announcements or group chat rooms in which the update can be viewed before coming. Since there is no real-time system, many students will usually end up having wasted their time and effort because their favorite meals or even ingredients have been exhausted when they arrive at the location. After reaching the cafeteria, students must stand in queue blindly at the stalls without knowing anything about the existing stock in the stall. Since the users cannot monitor the stock levels already in the food stall will end while queuing. Students need to stand in very long queues only to get disappointed upon reaching the stall counters. In addition, monitoring stall operational hours has not been organized at all. The closing time of the vendor is never announced digitally. Instead, the vendor monitors the stock level and closes as soon as they run out of stock. Without informing the students formally, operation hours vary significantly from one vendor to another, depending on peak times at the campus. Furthermore, there is no provision for keeping a record of the availability of the menu, prices, and timing daily. The students will not be able to refer to previous records or prices before going to the cafeteria. Besides, the transaction history and food trends are not documented at all for future reference. Moreover, there is no proper mechanism through which the menus can be shown, the inventory can be checked for its depletion, or any last-minute closing time can be notified to the campus populace. All in all, the present menu system presents a very inconvenient dining experience, which makes a digital system such as SCS highly desirable.
Assalamualaikum, my name is Nurunazila binti Bazlino, and today I will be presenting my part which covers the process of flow of the data in the current system, followed by the example of form input and example of report output for our smart cafeteria system project. First, I would like to explain the current process of ordering food at the UiTM Jengkel cafeteria. As shown in the flowchart, the process starts when a student arrives at the cafeteria. Since there is no online ordering platform, the student needs to walk to each food stall and manually check the available menu. If the selected food is unavailable, the student must choose another item from the menu before continue the ordering process. This situation can be inconvenient because students only know whether the food is available after arriving at the stall. Once the food is available, the student queue at the selected stall and place the order directly with the seller. The seller then receives the order and start preparing the food manually. After placing the order, the student proceed with the payment process. In the current system, there are two available payment methods, which are cash payment and QR code payment. After completing the payment, the student waits near the food stall until the seller finish preparing the food. Once the food is ready, the student collect the order and the process ends. Overall, this process is completely manual and depends heavily on face-to-face communication between student and seller. As a result, students often experience long queue, longer waiting time, and difficulty checking menu availability before arriving at the cafeteria. This limitation reduces the overall efficiency of the cafeteria service. Next, I will explain the example of form or inputs in the current system. The first input is food ordering information. This information is entered when students place their food orders directly with the seller. Students verbally communicate the food item they would like to purchase, including the quantity and any special requests if necessary. Since there is no computerized ordering system, the seller relies entirely on verbal communication to receive and remember the customer's order. During busy periods, this manual process increases the possibility of miscommunication or incorrect orders. The second input is payment information. Once the food order has been placed, students complete the payment using either cash or QR code payment. Although QR code payment is available, the payment process is still not integrated with cafeteria management system. This means transaction information is not automatically stored, making it difficult to monitor sales records or generate transaction reports efficiently. Therefore, both food ordering information and payment information are essential inputs that enable the ordering process to be complete in the current system. Finally, I would like to explain the example of reports or outputs produced by the current system. The first output is food collection. After the seller has completed the food preparation process, students collect their food directly from the stall. Since there is no digital notification system, students are required to wait near the stall and check manually whether their food is ready. This often causes congestion around the food store, especially during lunch hours. The second output is the payment receipt. For students who make payments using QR code, a digital receipt is generated by their banking application or e-wallet as proof that the payment has been completed successfully. However, it is important to note that this receipt is generated by the payment provider instead of the cafeteria itself, because the current cafeteria system does not have an integrated information system to generate its own digital receipt or transaction record. In conclusion, the current cafeteria system still operates manually. While it is able to support basic food ordering and payment activities, several limitations such as manual ordering, Lack of real-time information and the absence of an integrated management system affect the overall efficiency and convenience for both students and sellers. That concludes my presentation. Thank you.
Assalamualaikum and hi, my name is Salia Sofia binti Abdul Rahman. I am from class BA262. So for my part, I will explain more about the problem statement of a cafeteria. We identify the 6 main problems in the current cafeteria that affect both student and cafeteria staff. Now let me explain each problem one by one. The first problem is related to price transparency. Currently, students cannot see the price of food and drink before they arrive at the cafeteria. For example, imagine a student only has RM7 to spend. Since there is no price list available, the student must queue first before finding out that the meal costs RM9. As a result, the student has wasted time waiting in line and still cannot buy the meal they wanted. Therefore, students should be able to view the food price before going to the cafeteria so they can plan their budget and make a better purchasing decisions. Moving on to the second problem, which is the lack of livestock updates. Now, students cannot check whether the food item is still available before they go to the cafeteria. For example, a student wants to buy a fried chicken because it is their favorite menu. However, after waiting in a long queue, they are informed that the fried chicken is already sold out. This situation wastes time and often leaves a student disappointed. If there were real-time updates, students could immediately choose another menu without having to queue unnecessarily. Next, for the third problem is inefficient time management. Students must walk to the cafeteria, queue to place their order, and then wait again for their food to be prepared. During lunch hours, this process can take quite a long time because many students are buying for food, leaving very little time to eat before the next class begins. This reduces student productivity and may even cause them to arrive late for the class. The fourth problem is the absence of a digital ordering system. Currently, the cafeteria does not provide a mobile application or a website where students can browse the menu, place order, or make payments online. Everything must be done manually at the cafeteria. For example, even if students already know what they want to eat, they still need to visit the cafeteria, wait in line, order the food, and wait again until it is already. This manual process increases the waiting time and causes congestion, especially during peak hours. Previously, before this, students only used a personal shopper or runner without any real-time tracking feature. Students did not know where the personal shopper and runner was or the current progress of their order. At the same time, the student also faced difficulty in monitoring the personal shopper status. This lack of visibility reduced transparency, caused uncertainty, and could lead to lower customer satisfaction, especially when deliveries were delayed. The final problem is related to menu availability. Students do not know which menu food items are still available before they queue. For example, a student may come to the cafeteria specifically to buy nasi lemak, but after waiting in a line, they discover that it has already sold out. As a result, they need to choose another menu, which takes additional time and causes frustration. At the same time, cafeteria staff are frequently interrupted by students asking whether certain menu items are still available. This slow down the ordering process and reduce overall efficiency.
Next, I will explain the proposed system for our smart cafeteria system. This proposed system is designed to improve the current manual cafeteria system by introducing a digital mobile application that provides real-time menu updates, online food ordering, order tracking, and better communication between users and sellers. In this section, I will explain the objective of the new system, the scope of the system benefits, the process flow of the new system. The Smart Cafeteria system has 5 main objectives. First, it allows sellers to update menu availability and food stock in real time so students can check before visiting the cafeteria. Second, it speeds up the ordering process through the mobile application. Third, it improves communication between users, seller, and delivery runners through the chat feature. 4. User can track their order status. Finally, it helps cafeteria seller manage menus, customer orders, and stock more efficiently. The system is designed for 4 types of users, which are students, lecturer and staff, cafeteria sellers, and student runners. Student and staff can browse menu, place order, make payments, and track their orders. Seller manage the menus, price, and customer order, while runner delivery food and update delivery status. The system will be implemented within UiTM Jelka, including College Tok Gajah cafeterias and Campus Smart, and it is accessible through a mobile application. The Smart Cafeteria system provides benefit to all users. Students can check menus, order in advance, and track their food in real time, which help reduce waiting time. Seller can update menus, manage stock, and keep proper transaction record. Student runners benefit from organized delivery management, while the university benefits from supporting digital transformation and improving service quality. The process begins when users open the Smart Cafeteria application and browse the available menu together with food price and stock availability. After selecting the food, user place the order and choose either online payment or cash payment. The seller immediately receives the order through the system and prepares the food. Once the food is ready, the seller updates the order status to ready. Finally, the system sends a notification to the customer so they can collect their order without waiting unnecessarily.
In our use case diagram for Smart Cafeteria system, as you can see here, there are two main actors, which are student as a user and cafeteria staff as a seller. First, student must log in into the Smart Cafeteria using a registered email and password to securely access to the system. During the login process, the system verifies the user credential to ensure that only authorized users can access the features such as browsing the menu, placing order, making payments, and viewing order history. Next, students can browse the digital menu to view available food and beverage items, including their names, price, description, and image. While browsing, the system automatically checks the availability of each item and display whether it is available or sold out, helping students to make informed decisions before placing an order. After browsing the menu, students can select their preferred food and beverages and specify the desired quantity for each item. The system records the selected item, calculate the total cost based on the quantity chosen, and prepare the order for submissions. Next, students can complete the payment after placing the order by selecting a preferred payment method, either cash or QR code. Once payment is successfully processed, the system generates a payment confirmation and updates the order status, ensuring that the cafeteria staff can proceed with preparing the order. Next, the system will send a notification to students whenever there is an important update regarding their order. For example, students receive an order ready notification once the cafeteria staff have completed preparing their food, ensuring timely collection and reducing waiting time. After receiving the notification that the order is ready, students proceed to go to the pickup counter to collect their food. This process helps to organize food collection efficiently while minimizing congestion and long queue at the cafeteria. Students can access their order history to review previous purchase, including food item order, payment details, order dates, and transaction status. Their feature allows students to keep track of their spending and easily reorder their favorite meals. Lastly, after the food has been successfully delivered and the order status is marked as a complete, students can provide a rating 1 until 5 star and submit the feedback based on their experience. The feedback may include comments on the food quality, the delivery service, or the accuracy and overall satisfaction. The submit rating and feedback are stored in the system, allowing cafeteria seller and administrator to review the customer opinions, identify areas for improvement, resolving the recurring issue, and enhance the overall quality of food and service. This feature also help the future student to make more informed ordering decision based on previous student review. For cafeteria staff, log in into the Smart Cafeteria system using authorized staff credential to access administrative function. Secure login ensure that only authorized personnel can manage menu, update food availability, process customer order, and access sales report. Cafeteria staff also can add the new menu items, edit existing food information, or remove unavailable items from the system. This ensures that the student always have access to an accurate and up-to-date digital menu. Besides that, staff can update the availability or stock status of food item whenever inventory change. The system immediately reflects these updates, allowing students to see which items are currently available and preventing order for sold-out meals. Cafeteria staff can modify the price of food and beverages whenever necessary. The update prices are displayed instantly in the system, ensuring that price transparency and allowing students to view accurate pricing before placing an order. The cafeteria staff receive incoming customer order through the system, where they can view complete order details, including selected menu items, quantity, payment status, and customer information. This enables staff to prepare order accurately and efficiently. After reviewing the received order, they prepare the request food according to the customer order details. The preparation process begins only after the order has been successfully received and confirmed by the system. As the food preparation progresses, they will update the order status in the system from preparing to ready for pickup. This update automatically informs the student about the progress of their orders and improve communication between both parties. Lastly, the system allows cafeteria staff to generate and view sales report containing transaction records, revenue summaries, and other statistics. This report helps the staff monitor business performance, analyze sales trend, and support better decision making for cafeteria operations.
Next is proposed form. UiTM Jenkins Smart Cafeteria System is a complex of various interconnected forms that help simplify dining, shopping, and delivery process for students and staff members. Form within the application is a mechanism of collecting and showing the information that enables connecting users, merchants, and students as deliverers. Every form suggested in the system is designed for a particular step in working with it, from registration to information research and checkouts in the online marketplace and logistic and communication control. The system provides a secure and efficient environment, and it eliminates the need for students to stand in lines to find out whether some products is available. The process starts with the user login and registration form that is the security entrance to the entire system. Every time students or employees access the application, they will be asked to confirm their identifier by login or registering an account. The user can enter UiTM credentials to log in and automatically create a profile with addresses, orders history, and preferences. Upon authentication, the user can access the system, which includes Cafe Talk, the For You page, like FIP, feed based on the short form information from campus vendors, featuring daily menus and promotion. In direct purchases, there are two main types of digital shop interfaces used in the system. These are the cafe vendor order interface and the campus smart checkout interface. Using the cafe vendor interface, users get to look through menus, check out live availability of products and individual stores, and place meals straight into the cart. The same way, the campus smart interface works as a digital co-op, allowing students to look around and place their daily students' needs like Maggi, noodles, milk, toothpaste, or shampoo straight into the cart from within the comfort of their door. After confirmation of an order, the system shifts to back-end logistics via the runner checklist form and the runner tracker form. Runner checklist is a dynamic form meant for delivery. Runners will act as a students. It acts as a checklist form to provide a structured task checklist of all items to pick from the vendor or cooperative. On the other hand, the user gets information regarding order process through runner tracker from that displays active order milestone from assignment to completion. Picking up the entire order process is the merchant, runner, and customer checkbox, which is an instant message box through which a user can communicate with vendors and delivery runners in real time. Moving on to the system interface, this is the onboarding gateway which serves as the primary entry point to our application. As you can see on the slide, we have carefully designed this interface to establish a strong institutional alignment and corporate identity. This is achieved through the integration of prominent system branding paired with a clear, descriptive tagline that outlines our core objective, managing and simplify campus food logistics to support backend architecture of multi-sided platform. The onboarding processes immediately introduce role-based segmentation. The interface incorporates specific users classification tags that systematically divide our target audience into three distinct functional categories: students, vendors, and runners. This ensures the right from the very first interaction, each user type is directed toward a customized experience tailored to their specific operational needs within the smart cafeteria system. Next, let us look at the registration and signing interface, which functions as the system's first security checkpoint for user validation. To optimize access control right from the start, the form features an initiative role selection card system. This allows users to easily switch between students, vendor, and runner roles depending on the specific authentication pathway required for their account. To minimize user friction during input, the interface implies credential entry by combining user-friendly fields to the for the institutional email or metric ID with a helpful password visibility switch for accuracy. Finally, the form balances security with smooth user navigation for embedding essential secondary triggers such as the forget password, link, right, alongside our primary call to action button sign in as students to complete a seamless and secure verification process. Now let's move on to the home screen, which serves as the central navigation hub and primary focal point for the entire application. Our main design goal here was to create a seamless initial interaction between the system and the user. We achieved this by placing a personalized greeting banner right at the top of the screen, making the platform feel welcoming and user-centric. Directly below that, we integrated a quick access grid. This grid provides immediate shortcuts to the core functionalities of the application, specifically food ordering and real-time tracking, ensuring that users can complete their main tasks with minimal effort. Additionally, to bridge the communication gap on campus, the screen features Cafe Talk. This innovation module allows campus vendors to broadcast urgent, time-sensitive messages or permissions using highly engaging familiar social media format. Next, let us look at the cafeteria store listing page, which serves as the system's centralized digital directory for various campus vendors. The core objective of this page is to drive better user decision making. To achieve this, we implemented an organized cart layout that clearly aggregates vital data for each store, such as their specific cuisine categories, estimated preparation times, live operational status, and user rating. From an operational standpoint, the interface includes smart design features to manage customer expectations, such as conditional banner alerts that instantly notify users if a vendor is currently closed. For active vendors, a prominent view menu and order call to action button is embedded to provide an immediate pathway into the transaction process. Finally, this entire screen is systematically integrated with the global bottom navigation bar, allowing users to move smoothly between browsing food options and the main areas of the application. Moving on to the retail segment of our application. This can represent the campus marketplace. It essentially functions as a dedicated e-commerce catalog designed specifically to bring the campus cooperative shopping experience directly to the students online. To maximize visual efficiency, the interface utilizes a structured two-column grid layout. This allows users to scan through availability stored seamlessly by presenting clear product imagery, item names, descriptions, and localized pricing at a single glance. To minimize purchase friction and keep the user journey as smooth as possible, we have incorporated the two critical interactive elements. First, at the top of the screen, you will find horizontal filters and allow students to quickly sort through categories like snacks, instant foods, or fresh produce. Second, each item cart contains a direct add to basket action button, enabling users to boot their cart instant without needing to navigate back and forth between multiple pages. Next, look at the runner tracker interface, which serves as our live tracking and communication dashboard for orders that are actively on the way. To eliminate the uncertainty of manual system, this screen drastically increases logistic visibility by integrating an interactive map. This map illustrates the exact route the student runner takes from the cafeteria food court straight to the user's dorm or location, complete with a live ETA and tracking identifiers. Beyond just mapping, the interface provides complete fulfillment transparency through our personal shopper checklist. This feature allows the customer to monitor the item picking process in real time as the runner compiles the order. Finally, to ensure smooth coordination and resolve any last-minute issues, we have designed a dual-table communication interface. With a single tab, users can conveniently switch between separate dedicated chat windows to speak directly with either the vendor machine or their assigned delivery runners. Next is the Your Card checkout page, which serves as the last critical interface for users to verify their order details before finalizing any financial transaction. To streamline the purchasing process and prevent errors, this page aggregates all essential data in one place, displaying a comprehensive summary of selected cafeteria meals, total item counts, and localizing pricing. It also features initiative plus and minus quantity controllers, allowing users to make live last-minute adjustments directly on their screen. To accommodate different user needs on campus, the interface explicitly segments logistics preferences into two clear choice modules. Users can either choose a personal shopper delivery with a transparent running fee or select the free self-pickup option. Below the fulfillment choices, the interface incorporates dynamic discount banner notifications and versatile payment gateways, giving users the flexibility to settle via cash or a digital QR code. Everything leads down to a transparent pricing breakdown and a prominent, highly visible place order call to action button to complete the purchase securely. Lastly, let us review the user profile screen, which acts as the central management platform for users to verify their personal account details and transaction history. To keep the interface clean and organized, we have placed a dedicated profile hidden right at the top of the screen. This section aggregates all essential user identifiers, including students' ID, faculty affiliation, and campus residence details positioned right next to the account logout functionality for quick access. To promote financially and promote operational accountability across the platform, the lower section of the screen introduces a structured horizontal tab system. This allows users to easily filter their transaction histories into three clear categories: active, completed, and cancel orders. Under each tab, the system maintains a comprehensive ledger that tracks critically transaction data, including full order summaries, precise receipts, timestamps, total amount spent, and item counts, giving students total visibility over their campus dining and shopping history. That's all from me.
The proposed smart cafeteria system generates 5 digital outputs. These outputs improve record management and provide better information for both student and cafeteria sellers compared to the current manual system. The first output is the order confirmation report. It is generated immediately after the student places an order. The report includes the student information, food item order, quantity, total price, payment method, seller's name, and current order status. This allows users to confirm that their order has been successfully submitted. The second output is the digital payment receipt. It is generated after a successful online payment using QR code or online bank-in. The receipt records the payment amount, payment method, payment date, payment time, and payment status. For cash payments, the system indicates that payment will be made during food collection. The order status notification is automatically generated when the seller finishes preparing the food and change the order status to ready. The notification informs the student that the food is ready for collection, helping reduce unnecessary waiting time at the cafeteria. The final outputs are the order history report and seller transaction report. Students can review their previous order, payment history, and order status. Cafeteria sellers can monitor daily sales, total order, food availability history, and transaction records. These reports support better business management and decision making.
I will conclude our presentation. In conclusion, the smart cafeteria system is designed to solve the current problem faced by student, lecturer, and cafeteria seller at UiTM Jenker. Instead of relying on manual methods, users can easily check menu availability, food stock, and cafeteria operating hours through a mobile application. This makes it much easier for everyone to access accurate and up-to-date information. Besides improving the experience for student and lecturer, smart cafeteria system also help cafeteria seller manage their business more efficiently. Seller can update menu items, change food availability, and notify customer instantly through the application. As a result, misunderstandings are reduced, customers are less likely to be disappointed, and the overall cafeteria service becomes more organized. Overall, the smart cafeteria system demonstrates how digital transformation can improve everyday service within the university. By integrating technology into cafeteria operation, smart cafeteria system promote convenience, efficiency, and effective communication for all users. We believe this system has the potential to enhance the quality of service cafeteria service, while supporting UiTM vision of becoming a smarter and more technology-driven campus. I think that's all from me. Thank you.